So another type of loop that people use a lot is the while loop. It's similar to the for loop. We're going to do something repeatedly, but the difference is we're not going to do something for every element in a list. We're going to do something while some condition remains true. So what that means is that it will do while, it will check the condition, it will check whether this is true or false. If it's true, it will run all the code indented under the while statement, and then it will try and run again. It will check the condition. If it's still true, it'll run it again. If the condition is then false, when it gets to the top again, it won't run the while loop anymore. So it will go through line by line, reach the while statement, check the condition. If it's true, run all the code, and then recheck the condition. If the condition is false, it will skip to the end. So the important thing to be aware of when working with while loops is that it only checks the condition when it's back at the top of the loop. So if the condition is true, it's going to run all the code under the while statement. Even if the condition becomes false during that execution, it's still going to finish running all the code that's indented, then go back to the top and check the condition. If the condition is then false, then it will stop. So here's an example of that. I start with loop condition equal to true. The other thing I should mention while we're working with while loops, in case anyone comes across it, is how to get out of an infinite loop. So if I have my condition equals true, and I run while my condition print something, and you get this infinite loop. If you hit Control and C, you pass Python what's called a keyboard interrupt error that will get you out of the loop. So if you make a mistake while working with this and everything starts going crazy, hit Control and C. Okay, so here I've set my loop condition equal to true, and then I have while loop condition. You can have anything here as long as it evaluates to true or false. So it's going to check whether loop condition is true. It's going to be true the first time because we've just set it to true, and therefore it's going to run all the code that's indented underneath loop condition. So it's going to set the loop condition to false, it's going to print that this will print once, and then it's going to go back to the top of the while loop and check what loop condition is. Now, loop condition is false. So it's going to finish, execute the code, and you should see that printed only once. So just to recap one more time, sets the loop condition to true, we're going to check the loop condition. The loop condition is true, so it's going to run all the code. The code it does is set the loop condition to false, but it's not checking this condition at this point. So it's going to keep going. We've set loop condition to false, we're then going to print that this will print once, and then it goes back to the top because we've reached the end of the indented code, and now it's going to check the while loop condition. Now we know the condition is false, so it's finished, and it jumps to the end of the code. So that's only executed once. So just the take home from this is that the while loops will run all of the code that's indented underneath them if the condition is true when it's at the top. It will then run all the indented code and then check the condition again. If the condition is false when it's checking again at the top, it won't run the indented code anymore. So it will keep going through again and again and again while that condition remains true. Does that make sense? Okay. So here's an example. I start with a count set equal to 0. I want to do something while that count is less than 10. So while the count is less than 10, colon, new line, indentation. What do I want to do? Well, I want to print the count, and then I want to add 1 to the count. Remember, count plus equals 1 is the same as saying count equals count plus 1. So whatever value count currently has, we're going to add 1 to it. So count will start at 0, it will print 0, and then it will set the count to 1. It's going to check whether count is less than 10. 1 is still less than 10, so it's going to do it again. It's going to print 1, it's going to add 1 to 1. Now we know that count is going to be 2, and it's going to go back to the top and check whether 2 is less than 10. It is, and it's going to keep going all the way through like that. So when you run that code, what you should see is 0 to 9 printed to the screen. If you then type count to just check what value count has, you'll see that it's actually 10, and the reason it's 10 is because it printed 9, it then add 1 to the count, made it 10, checked whether 10 was less than 10 and it isn't, and so it didn't do anything else, but it has already updated count to 10. So because the print statement comes before the adding 1 to the count, when the code finishes, count is 10, even though only 0 to 9 was printed to the screen. So let's say we wanted it to print all the way up to 10. How might we do that? Any ideas? Yep, that's definitely one way. We can do less than or equal to, and then it will print 0 all the way up to 10. Anything else we might be able to do? So the alternative is to switch the order of the print and the count. If we add 1 and then print it, we should see all the numbers not from 0 to 9, but all the numbers from 1 to 10 printed. I don't remember which I chose. Okay, so I switched the order of the statements, and now when you run it, it will start with count equals 0, it will add 1 and then print it all the way up to 9. 9 it will add 1 and then print 10, then it will check the condition. So if you switch the order of the statements, you get all the numbers between 1 and 10 printed rather than 0 to 9. Does that make sense? Everyone with me? Any questions about those while loops? Good, okay. So we can actually combine these while loops with the raw input function that we used before. Again, just a reminder that if you're on Python 3, the raw input would be the input command that was replaced with input in Python 3. So this example, what it's going to do is it's going to ask the user a question, and it's going to use a while loop to keep asking them the question until you get the right answer. This is a trivial example, but you often need to do something like this if you have a piece of code that asks for a gene of interest and then it does something on that gene. Perhaps it scans a gene list and looks for the gene and does something with it. If they type something wrong that's not a recognized gene or isn't even a string, you might want to ask the question again until you get a valid answer that you can do something with. So here's how you might do that. I'm going to start with an empty string called choice, and then I'm going to do something while that choice is not equal to Python. So while the choice is not equal to Python, I'm going to use raw input to ask what language are we learning, and I'm going to store their answer in the choice variable. So what language are we learning? If they type Java, choice is not going to be equal to Python, so it's going to ask them again. And it's going to keep asking until they get a perfect match to the word Python. And it should keep going, and the case will even matter. Can everyone see why that keeps asking the same question again and again until you get the right answer? So the while statement will check the condition, and if it's true, it's going to keep asking, and it's going to be true if the choice is not equal to Python. So if the text choice is not equal to Python, it's going to ask again and again. Once the user types Python, the choice will be stored as Python in that variable, and so it will then become false. With choice not equal to Python will become false because choice will be equal to Python, and then it will stop asking. Great, okay. So we saw break statements before, and we know they can be a little tricky. With a for loop, it kind of makes sense. You want to do something again and again and then break if it's true, and the same break in a certain condition, perhaps when you've found the input you need. You can do the same with a while loop, and it's very tricky because sometimes you look at someone's code and it looks like it's going to do something 100 times, it only does it 10 times, and it's because there's a break statement like this in there. Okay, so here is an example. I'm starting with a count equal to 0, very similar to an example we saw before. While the count is less than 100, I want to do something. What I want to do is print the count and add 1 to the count. So all of that code up till that point looks like it's going to loop all the way through from 0 to 100, printing all those numbers and adding 1 to the count every time. However, we're going to make sure it doesn't by having an if statement here, which checks whether 100 divided by the count is less than 10, and if it is, it breaks. So if 100 divided by count is less than 10, which will become true as it hits 11, I want to break, and that will break the while loop that we're in and finish executing the code. And so what we see printed to the screen is all the numbers 0 to 10, rather than all the numbers 0 to 100 as we might expect. So the while condition actually never becomes false. So the while count is less than 100 is never used. It never triggers from true to false. What stops the while loop executing is actually this break statement that happens once 100 divided by the count no longer becomes less than 10. Can everyone see why that prints all the numbers from 0 to 10 rather than all the numbers from 0 to 100? Lots of nodding. Awesome. So we saw if and else statements, and that makes some sense. You know, if something is true, do one thing, else do something else. You can also have while and else statements, which doesn't make quite as much logical sense, but all you need to know is that an else statement is triggered if a while loop finishes without reaching a breakpoint. So in this previous example, we saw that the reason the while loop finished was a break statement. It wasn't this condition turning to false. So an else statement in line with a while statement will only trigger if the condition has turned from true to false and the while loop has finished for that reason. If the while loop finishes because of a break statement, the else will never get triggered. So I don't expect you to type this entire example, but it's what it is it's a way of running a random number game, where a user has to guess a number that the computer generates, and we're going to use the break statement to make sure that we don't print that they lost if they get the number right. So I do def random number game, defines a function called random number game. I'm going to generate a random number using this randRange function. To get that function, you might need to do from random import randRange. I think it's in the random module in Python 2. So I generate a random number between 1 and 10. What I do is I then start with a count set equal to 0, and this is going to be how many guesses the user has had so far. While that count is less than 3, so I'm going to give them 3 guesses, let's store their guess as an integer, so convert whatever they type to an integer in case they type some decimal number. It's going to be very hard to guess numbers on the real numbers. So let's guess, let's store their guess, let's ask them to guess a number, let's use raw input to get their answer, and let's convert it to an integer and store it in this guess variable. So it's going to say guess a number, they're going to type 5, it's going to store that in this guess. If the guess is equivalent to the random number that we generated, we print you win and we break. So that will exit the while loop and finish the code. If their guess is not equivalent to the random number, let's add 1 to the count, then it will go back to the top of the while loop, find that the count is 1, 1 is less than 3, it's going to give them another guess. It'll add 1 to the count if they get it wrong again. Once the count gets to 3, it will say 3 less than 3 is false, so the while loop will finish. Because the while loop finished with the condition turning from true to false, the else statement will be executed and it will print you lost. So the only reason the else statement is executed is because the while loop finished with the condition turning from true to false rather than from the break statement. So you can imagine going through your genome, looking for a gene, and breaking if you find it, and doing something when you found it, and having an else statement where it says your gene isn't in this genome that we gave. So you would do something different if you finished your while loop with a break versus if you finished your while loop because the condition became false. So that's where the else comes in. Again, you probably don't make wide use of while and else, but you'll find lots of people do, and it's good to be familiar with it, at least to figure out why it's triggering. Everyone follow this else statement? Okay, fantastic. And that's how it plays. You can go back to the slides afterwards and figure it out if you want to. Okay, so what we're going to do is take this reverse complement function we wrote before, and previously we used a for loop to do something for every nucleotide in our sequence, but what we can also do is use a while loop. So the code on the top left figures out the reverse complement using a for loop. The code on the bottom right does the same, but it uses a while loop. Now, I'm not saying one of these is better or worse than the other. Whichever, there's no real performance difference on the small data sizes we're looking at. So basically use whichever you're most comfortable with, whichever makes the most sense to you. Personally, I write a lot more for loops than I do while loops, but it's up to you, whichever clicks and helps your understanding. So most of the code looks the same. We still define a function, we still define this empty sequence, and we still need our complement dictionary. The difference is the for loop would set nuke equal to the first letter the first time, the second letter the second time, all the way through our sequence. The while loop doesn't do that. The while loop just checks a condition. So we have to make a couple of tweaks to our code now that we don't have this variable automatically setting. So I'm starting with a variable called count, and I'm setting it equal to 0, and that's going to count how many letters through our sequence we are. And while the count is less than the length of our sequence, I want to keep going. So it's going to start with 0, and it's going to go all the way until we reach the end of our sequence. So while the count is less than the length of the sequence. What I want to do is every time I previously used the nuke variable, which was automatically set by the for loop, I want to instead use I want to get the nucleotide in my sequence that is at the index count. So rather than nuke being automatically set to the first letter the first time, the second letter the second time, I'm using my count, which starts at 0, to get the 0th letter from my sequence the first time, and then adding 1 to the count at the end of my while loop and getting the next letter the next time. So everywhere that I had nuke before, I now need to use seek square brackets and then put the count in that sequence. The eagle-eyed among you will see that I missed one here. So this nuke also needs to be seek count, because nuke isn't defined in this code, so that's an error. Keep an eye out for that. But basically what this will do is it will get the first letter of our sequence the first time, do all the same code, still check whether it's an AGCT, and still prepend the value in the dictionary that corresponds to that nucleotide if it's valid, and go through like that. The final thing we have to do is add 1 to the sequence by doing count plus equals 1. Remember, that's the same as doing count equals count plus 1. And by doing this, we will go through the sequence all the way until this count is no longer less than the length of the sequence. So these are both similar. I find the for loop easier because it automatically sets this variable for me, and I can just use nuke. But there are certain conditions where while loop might be easier, and whichever you find easiest to think about. So if you run these code, you'll get the same result. Okay, we're at 11:30. I'll just briefly go through this. It'll take 2 seconds. So the final thing I want to talk about today is errors. We've all come across errors in our code. A bunch of you have been typing and you'll see loads of errors. Don't worry about them. It's fine, it's normal. Even if you get, it says scary words like illegal or hardware or anything, don't worry about it. They are useful and they help you debug. So here are a few of the most common error types we come across. Syntax errors are some of the most common, but also some of the most least informative, because it just means what you wrote is not valid Python. So can anyone see why we're getting a syntax error in this code? I've typed while true, I've hit enter, and I'm getting a syntax error. So what's missing? What's wrong? Exactly. So I've missed a colon from this line, so it's invalid Python, and it's telling me that it's invalid Python. So this error message looks scary and useless, but if you break it down, it's actually pretty useful. What it tells you, and what every error message will tell you, is first what file had the error. This tells me that it was on the standard input. If you're calling a file that then calls another file in a big load of functions that you've written, this will help you narrow down which file to look in. But because this happened in the interactive environment, this is always going to stay standard input. So I got an error on my standard input. It tells me what line my error occurred in. Again, this is useful if you're working with a big file with lots of lines and they're all referring to each other. So I know to look on my standard input. I know to look on my first line. And then it sort of gives you an arrow that approximates where the error might be. This arrow will not always be exactly right, because sometimes Python manages to stumble on and try and figure out what you've written, and the arrow might come a little bit before or a little bit after. Here it's got it pretty close. We've got an arrow showing at the end of the line there's some invalid syntax. So we know now that we need to add a colon at the end of that line. Indentation errors are exactly as you might expect. So I correct the colon, I start typing print test, I get an indentation error that tells me that somewhere around the start of this line, on my second line, because this is my first, so this is my second, it expected an indented block. So the issue was that I didn't press tab after doing my colon. As you get more and more familiar with Python, you'll get used to doing colon new line indentation. So because I didn't indent my code, I get this error. So we correct it by adding that tab. Exceptions are errors that occur when you've written valid Python code, but it doesn't work for the inputs you've given. So if you write code that's valid, it's valid for numbers, it does a load of maths, but the input you give it is strings or dictionaries or something else, you might get an exception because you've written valid Python code, but Python doesn't know how to do it with the inputs you've given it. So exceptions are slightly different. There's a whole bunch of them. Name errors mean that you've referred to an error. You've referred to a variable that doesn't exist yet. A divide by zero error means you try to divide by zero. We've seen the keyboard interrupt exception previously when we got stuck in an infinite loop and we hit Control-C. That's actually an exception that we can handle. So that's a keyboard interrupt exception. Type errors means you try to do something on the wrong data type. So if I try and get the length of a string, it'll work. If I try and get the length of a number, it won't work. So it doesn't know what the len of 1, 2, 3 is. So I get a type error that tells me that objects of type integer don't have a length. And input object errors we'll come across tomorrow when we work with files. If you try and open a file that doesn't exist, you might get an input object error.